All right, so here's part 2 of the video for simplifying these radicals. And so this second part, we're going to look at breaking them apart if you're dealing with division. And so these first couple aren't too bad, but they'll get a little bit more challenging as we work down the page. So you can kind of see right here. So if you're square rooting a fraction, if you're taking the square root of a fraction, you can actually break it up and they can each have their own radical, and you can kind of simplify it there. Now, if you can simplify prior to breaking it apart, you'll want to do that, and that's what we're going to see as we kind of work down the page. And then just another little note, the square root of 1 is going to be 1, and that's true for any index. And so far, we've only dealt with square roots, but the next lesson we'll start to incorporate other roots. And so we'll worry about that in the next section. Okay, so if we look right here on 15, you can see you've got 49 over 81. Those two numbers don't simplify, but what I can do is I can just go ahead and break this up into the square root of 49 over the square root of 81. And then I can square root each one of those. So it should be a 7 over 9. 7 over 9. And there you go. That's your answer. Okay, and so 16 is really not all that different. So we can break this up into the square root of 1 over the square root of 25. Okay, and so then the square root of 1 is going to be 1. And then the square root of 25 is going to be 5. And so there we go. So we get 1/5 right there. Okay. All right. So moving on. Here we're going to run into one that's going to be a little bit more interesting. So let's see. We've got 27 over 363. So I pulled out my calculator in case I need to use it here, but it does look like they're both multiples of 3. So let's check that out. So let's see. 27 divided by 3 is 9. Okay. And then 363, let's see, divided by 3 is 121. So what I can do here, I can kind of start by making life a little bit easier, because this fraction can get simplified. So we're going to simplify this into a 9 over, let's see, what did I say? 121. So 121. So I divided 27 by 3 and 363 by 3, so it reduced like that. And then now we'll go ahead and we'll look at go ahead and break it up like this. And then we'll square root each one of those. And so the square root of 9 is 3. Square root of 121 is 11. And there you go. Okay, so I think as we move kind of down the page, you're going to see some more that are going to be kind of like that. Oh, let's throw some variables in there, right? So not all that different. You kind of want to, so you're going to do the quotient rule first here. And so what happens, and so see, you got to know this is prior knowledge, that these 11 on top cancel out to where you're left with 1 over b to the power of, and it looks like that 27 would turn into a 16 when you reduce it. So these 11 cancel out with 11 on the bottom, so you're left with b to the 16 power on bottom. And so then now we'll go ahead and square root the top and bottom separately. Okay. And so square root of 1 is 1. And then the square root of b to the 16 will reduce down to b to the power of 8. And there you go, 1 over b to the power of 8. Okay, so we've got 3 left. And so now we're going to incorporate numbers and variables. So we got 64 over 4, so we can reduce that. So we could start with the numbers. So 64 over 4, that will reduce the top down to a 16. You can put a 1 on bottom if you want, but what's going to happen is these 5 x's on top will reduce with 5 on bottom. So this can leave us with x to the power of 12. So really, I probably wrote more of the radical than necessary. Okay, so then we'll go ahead and break these into their own radicals, the numerator and denominator. The square root of 16 over the square root of x to the 12th power. So square root of 16 is 4. Square root of x to the 12th would turn that into x to the power of 6. And there you go. Okay. All right. So looking at 20, obviously the numbers look like they're kind of getting a little crazy. So 605 and 245. Well, what I notice is they both end in the number 5. So that means they should both be divisible by 5. So that's where I'm going to start. So 605 divided by 5 is 121. So let me go ahead and start to rewrite this before I forget. So let's see, square root of 121 e to the power of 13 all over. And then I need to go ahead and do the same thing with 245. So 245 divided by, let's see, 5 gives us a 49. So now I have 49 and then e to the power of 5. Okay, so what I notice here is I can reduce the b's. The numbers aren't going to be reducible. They're just each going to get their own radical. But before I do that, I'm going to cancel these 5 out with 5 of these to where that's going to leave me with 8, be the power of 8 on top. So then when I break this up, I'm going to have the square root of 121 e to the power of 8 all over the square root of 49. And so then the square root of 121 is 11. And then the square root of b to the 8th become b to the 4th. And then all over the square root of 49, which is 7. And there you go. All right, last one. And so this time, so this previous problem, I noticed the numbers ended in 5s. This next problem, the numbers end in 0s, both of them. So they're both going to be divisible by 10. So I'm not even going to have to use a calculator here. So what's going to happen here is that 1,690 is actually going to reduce down to 169. And let's see, I've got x to the 49th power. And then on bottom, I'm going to be left with the 144 and x to the 35th power. There we go. And so I can reduce these 35 x's with 35 of these. I'm going to take off 35 from 49. That should leave me with 14. Okay. So then when I break it apart, I'm going to have the square root of 169 x to the 14th all over the square root of 144. And so the square root of 169 is 13. Square root of x to the 14th is going to be x to the 7th. And then the square root of 144 is 12. All right. And that is it.